Welcome to another example of the Lagrange multipliers, this time with three independent variables. In order to determine the maximum or minimum function values of f under the constraint of g, we're going to set the gradient of f equal to lambda times the gradient of g. That'll give us the first three equations as we see here. Then the fourth equation will be the constraint g equal to 0. Once we determine the values of x, y, z, and lambda, we'll determine which of these produce a max and min function value. Let's go and take a look at our example. So here we want to determine the minimum function value of f subject to 2x minus 3y minus 4z equal to 49. So the first thing we should do is probably recognize that g of x, y, z would have to be equal to 2x minus 3y minus 4z minus 49 equals 0. So now we'll set the gradient of f equal to lambda times the gradient of g. That'll give us these first three equations. So the partial derivative of f with respect to x, that's going to give us 4x equals lambda times the partial of g with respect to x, that would be 2. Second equation will be the partials with respect to y. So the partial of f with respect to y would be 2y equals lambda times the partial of g with respect to y, that's going to be negative 3. And then we'll have the partial of f with respect to z, that'll be 6z equals lambda times the partial of g with respect to z, that'll be negative 4. And then our constraint is the fourth equation. This will be equation 1, equation 2, equation 3, and equation 4. So what we'll do here is solve equations 1, 2, and 3 for x, y, and z, and then perform substitution into equation 4. So for equation 1, if we divide both sides by 4, we would have x equals 1/2 lambda. In equation 2, if we divide both sides by 2, we would have y equals negative 3/2 lambda. And then for equation 3, if we divide both sides by 6, we would have z equals negative 2/3 lambda. So what we're going to do now is use equation 4 and replace x, y, and z in terms of lambda. Let's do that on the next slide. Okay, so here's x, y, and z in terms of lambda. Here's equation 4. And then here's the substitution. Notice everything is in terms of lambda now. So we have one equation with one unknown. So now we can solve for lambda. Here we'd have lambda plus 9/2 lambda plus 8/3 lambda. Let's go ahead and add 49 to both sides. Let's go ahead and get a common denominator of 6. So this would be 6 plus, multiply this by 3 over 3, that'd be 27 over 6. Multiply this by 2 over 2, that's 16. This is 49 6 lambda. Go ahead and multiply by the reciprocal. We have lambda equals 6. Now that we have lambda, let's go back to the previous slide and determine x, y, and z. So now that we know that lambda is equal to 6, 1/2 times 6, that means x would be 3. Negative 3/2 times 6, that would give us y equals negative 9. And for z, negative 2/3 times 6, that would give us negative 4. So notice we only have one point to consider, which means it would be our minimum value. Go ahead and determine what that function value would be. So here's our original function. Here are the values that we found for x, y, and z. If we sub these values into f, we're going to get 147 as our minimum function value. And that's going to do it for this video. I hope you found it helpful.